Alright, I copied and pasted this from your textbook, so I'm doing this right here, page 123 in your textbook. I'm going to do the try these A. It wants you to write them in terms of I, so because I write big and write a lot, I'm going to come down here. And this is part A. I'm going to take the square root of negative 25 and I'm going to break it down into the square root of negative 1 times the square root of 25. And the reason that I do that is because I recognize that the square root of 25 is a perfect square. And we know the square root of 25 is 5. And then we've defined the square root of negative 1 to be I. So this becomes I times 5. Well, we have a proper way to write that, and normally we put the constant in front, or the number in front, and the I goes behind. Okay, so this becomes 5I. And it would be that way for any perfect square. The square root of negative 49, that would be 7I. The square root of negative 100 would be 10I. So any number that's already a perfect square, the square root of negative 9 is 3I. Please don't get that confused with the negative on the outside. The negative on the outside is completely different. That means negative 1 times the square root of 25, and the square root of 25 is 5. And then negative 1 times 5 is negative 5. So if the negative is on the outside, that simplifies down to negative 5. Okay, so negative on the outside is not the same thing as negative on the inside. Now, what happens if it's not a perfect square? 7. 7's not a perfect square, and 7 doesn't simplify. It's a prime number. So we still take the square root of negative 7, and we still separate it as the square root of negative 1 times the square root of 7. The negative 1 becomes an I, the square root of negative 1 becomes an I, and then we've got the square root of 7. Now over here we rewrote and we put the I behind the number. Right here, we're actually going to leave the I in front of the square root symbol, and it says right here, it explains, write the I in front of the square root instead of behind, because it can be confused when we put that I behind the square root. We want to make sure that we understand that the I is not underneath the square root. And if we put it back here, sometimes it's confused with, is it the square root of 7 times I, or is it the square root of 7I? Is the I already underneath there with it? So to avoid this confusion, we're gonna, anytime we use radical signs, we put the I in front. Every other time we put the I in back. So like here they put the square root of negative 9 is 3I. Okay, so that became I square roots of 7. Now, don't forget the rules that you have for simplifying. Okay, the square root of 12 simplifies. So we take this and we rewrite the square root of negative 1, and then we rewrite it as the square root of 4 times the square root of 3. Why do we do that? Because 4 is a perfect square. So this becomes an I, this becomes a 2, and that square root of 3 doesn't simplify anymore. So the final simplified version is 2I. We do put the I behind the 2, and then we put the square root of 3 at the very end. Okay, same thing for 150. We do the square root of, let's see, the square root of negative 1 times 150. That's 6 quarters, isn't it? And I'm thinking quarters because 25 represents a quarter. And if I have 6 quarters, I've got $1.50. So that means 25 times 6. and this becomes an I, this becomes a 5, and this stays the square root of 6 because the only factors of 6 are 2 and 3, and they're both prime, and neither one of them are a perfect square. So the final answer is 5I square roots of 6. All right, then the next thing you have to know is there is a thing called a complex number. So imaginary numbers are numbers with an I in them, have the square root of -1, and a complex number is made up of a real part and an imaginary part. And to make things even more confusing, every number that we've ever dealt with in the whole wide world, for example, this number 8 right here, is a complex number. It has a real part and it has an imaginary part. So if I take this and rewrite it, it becomes 8 plus 0I. That way you can see there's the real part and there's the imaginary part. Why do we do that? Why do we want to take just a plain 8 and make it complicated like that? Well, really, we don't want to. I mean, and that's not a common practice. But right now, to make sure that you understand that a complex number can be just an ordinary real number and have 0 imaginary parts, we just want to make sure that you understand that a complex number, you've worked with them before. You just didn't know that they were complex numbers. So this over here, we have, this is the real part. 5 is the real part. And 8I is the imaginary part. Identify the real part and imaginary part. So up here, they told us that A plus BI is the general form. It's the definition, kind of. And they defined I to be the square root of -1. So in this case, the A is 5 and the B is 8. Not that they ask you to do that, but you could in this case. So what is it when you don't even have, it looks like you don't have a real part, or you have as an imaginary part? Remember, there's no plus or minus sign in there, so this is, in this case, B is the square root of 10, okay? That's the imaginary part. That's the coefficient of the imaginary part. B is the square root of 10. This one can be rewritten as 0 plus I square roots of 10. So if this right here, this is the real part, and this is the imaginary part. Okay, and you could tell me that the value of A in this complex number, the value of A is 0, and the value of B is the square root of 10. Okay, this one you want to be able to separate the real from the imaginary part, so you just break this up into 2 fractions. Okay, you just simply put the 2 over here with the 5 and put the 2 with the 3, and you can do that because what's the rule for fractions? You add the numerators and the denominator stays the same, so that great big divide by 2 can be separated into each individual part. So it's 5 over 2 plus 3 over 2I. So for this one, this part right here, this is the real part. And this part right here, this is the imaginary. Okay, you could answer the problem by saying the value of A in this complex number is 5 over 2 and the value of B is 3 over 2. So A is the real part, B is the coefficient of the I in the imaginary part. Okay. So that's how you use I's, and I think in the next video we're going to learn how to add, subtract, multiply, and divide them.